We'll see that maybe next Thursday or Friday, we'll see, okay? This is one way. There is a second way. And basically, the second way is that at each time step t, you start from t equal to 0, and then at each time step t, what you do is to compute Wt as Wt minus 1 plus Rt and then you compute Qt as Wt minus, divided by K. And then you compute, again, Wt as equal to Wt, the previous one, which is not nice, so let me say Wt star, Wt minus Qt times K. At each time step you do that. So basically, you are applying the initial scheme, the initial numerical, you are applying your numerical solution to the initial scheme, not to the integral that we derived. You understand what you do. At each time step, you get some rain, you compute the value of the volume stored in the tank, and then you compute the discharge, and then you have to update the volume, because in a first step you compute the volume by only considering rainfall. And then, once that you computed the discharge, you have to update the volume. You see that there is an approximation here. It's clear. It's clear because you compute the volume twice. A first computation by considering only rainfall, so it's approximated, of course. And then you compute the discharge, and once that you knew the discharge, then you update the volume. So there is an approximation, it's clear. It's crystal clear that you are making an approximation. Because the way in which you compute the discharge is through a volume that is not correct. Because you are correcting it later. So it's clear that there is an approximation. It is the numerical approximation, it's something that we are used to deal with. Instead, if you use this first solution, there is still an approximation, a numerical approximation, because I'm referring to a finite difference. But it's an approximation that is less coarse than the one that I would take here. Because I computed, let me say, half of the integral. Okay. This scheme is more general. This scheme here is more general. This one is a bit less flexible. This is more general because you could add other discharges, other holes in the tank very easily. Instead here, this is not possible anymore. Okay. We will move forward next week on the solution. We will adopt this scheme. I'll explain you why, because it's more flexible. And let me conclude here. Sorry for pausing it, because I wanted to make sure that I could finish this first part of the exercise, and I didn't remember at the beginning the result of the integral. I had to think of it. And this is the result, and basically it comes out that Qt is equal to constant rainfall times 1 minus t to the power of minus t over k. This is the result for constant rainfall. Just copy it. And you see that basically with constant rainfall, the linear reservoir tells you that for increasing time, the river discharge tends to rainfall. basically, there is one thing, one final thing that I need to tell you, and I forgot to tell you at the beginning. I should have said this at the beginning. Rainfall here is expressed in volume of rainfall over the catchment over time. So basically, rainfall intensity needs to be multiplied by the area of the catchment. All the treatment that I did so far is relying on this premise. Rainfall is expressed as volume of rainfall over catchment over time, rainfall intensity. And intensity, of course, is given by something over time, and the something is the volume of rainfall, not the rainfall depth. Okay? Because otherwise you clearly see here that there is an inconsistency. If rainfall is expressed as a length over time, and the discharge is volume over time, you see that I'm missing a square length. And it's clear for everybody of you this. R is expressed in volume of rainfall over the catchment over time. Is this clear? Is this clear to you that the difference is the area of the catchment? So to get the rainfall expressed in depth over time, to transform it in volume over time, you just need to multiply it by the area of the catchment. This is why your exercise tells you the area of the catchment. Is this clear? Perfect. Sorry for not saying this before. Okay. Yeah.
When we save the word, in which format we should save our file? Beta file, PostScript, PDF,
I would say this is a question that is related to the graph, I think. Basically, what I do usually when I exit from R, I use the Q instruction, and it asks me, would you like to save or not? I say yes. And then, so why do you shake your...
No, I mean, because when you go to files and say with name,
yeah,
he asks a lot of...
no, I don't suggest you to save in this way. Okay. What you should do is, while you are exiting from the program, just reply yes when it asks you whether...
And how can I exit from the console?
Yeah, in this way, Q and parentheses, okay. Open and closed. Okay, do you get the question?